In 2.4, we are going to learn how to perform set operations on Venn diagrams that contain three sets. This image that we have in front of us is a Venn diagram. So you have your universal set and you have three separate circles which represent three unique sets. So this is what it would look like if we had a Venn diagram with three sets. This is a fun image of three sets that are intersecting. You have the top portion here, which is the word I'm. So that would be your first set at the top is I'm. The second set focuses on chilling, and the third set focuses on at home. And if you take a look at where they are intersecting, the I'm the first circle with the second circle would perform together as I'm chilling. The first circle with the third circle would give you I'm home. And if you look at the second and the third circle, we're looking at chilling at home. Whereas in the middle, where you would have all three intersecting, would be I'm chilling at home. It takes into account all three sets. So this is a nice little image to help you determine what each region is stating to you. Set operations on three sets. They give us the defined sets of the universal set, set A, B, and set C. Let's look at part A. It says find each of the following sets. A union parentheses B intersect C. So when I take a look at this, I know that I have set A to work with first, so I will write that down. So set A is 1, 2, 3, 4, and 5. And then we're going to do the union. And now we need to define the intersection of sets B and C. So I will focus on B and C, and I want to grab the intersection. So the intersection is when the two sets intersect what they have in common. So we can see they have a 2, 3, and 6 in common. So that will give me 2, 3, 6. That represents the intersection of B and C. Our next item that we want to focus on is this union. Union means to unite the two sets together. So without repeating, I will unite these. So I have 1, 2, 3, 4, 5, and 6. And this would be my final answer for this first one. All right, let's take a look at the next one. Using the same sets that we have outlined before, let me go ahead and do a little erasing on here. We want to find in parentheses A union B intersecting with, in parentheses, A union C. So the first thing we want to go do is find A union B. So we're focusing on A and B, and we're just going to unite those items together. So that will give me 1, 2, 3, 4, 5, 6, and 8. All right, and then we're going to do the intersection of that one. With the A union C. So now we're focusing on set A and set C. We're going to do the union of those two items, which will give you 1, 2, 3, 4, 5, 6, and 7 is what it looks like to me. 1, 2, 3, 4, 5, 6, 7. So that looks good. And now we are going to focus on the intersection. If we remember, the intersection is what they have in common. So they both have the 1, the 2, 3, 4, 5, and a 6. So the result for this one would be 1, 2, 3, 4, 5, and 6. So these look quite busy, but they're really not bad as long as you work with what's inside parentheses, gather that together first, and then go back in and focus on the next operation. All right, and then for part C, let's see if I can squeeze that one in here. That has A intersect with B union, the complement of C. So we need to go find the complement of C. So the complement of C is going to be items that are in the universal set that is not included in C. So I'm focusing on set C, universal set. And I will eliminate the items that are in set C, which is 2, 3, 4, 6, and 7. So the complement of C leaves me with 1, 5, 8, and 9. All right, now that we have the complement of C, what I want to go grab is the intersection. Let me write this out here so we can see it. A intersect B union complement of C. All right, so set A. Let me rewrite set A. 1, 2, 3, 4, and 5. And let me get rid of my little marks that I had above here. And then I'm going to say intersect. And now I want to focus on B union C. So we want to look at set B and, I'm sorry, the complement of C. We want to look at those two items and we want to do the union of them. So to unite those two items, we will end up, those two sets will end up with 1, 2, 3, 5, 6, 8, 9. And we'll double check 1, 2, 3, 5, 6, 8, 9, and that looks good. So the last thing we need to do is this last intersection of those two sets. Again, the intersection means what they have in common. And we can see they both have a 1, 2, 3, and they also have the number 5 in common. So the answer would be 1, 2, 3, 5. And this would be the final answer for part C. So take it one at a time. Go for what's inside the parentheses first, then go for the outer operation. And let me draw some little lines here. So we did B intersects C, and that's the result right here. We did A union B, which is this first result. Then we did A union C, which is this second result. And then we did the final intersection. And then on part C, this is my set A. And this is B union the complement of C. So once again, we have our sets defined, the universal set and sets A, B, and C. And they want us to find a special operation. So we're looking at A union B in parentheses intersect with A union C in parentheses. So we'll focus on A union B first, which tells us we need to grab sets A and set B and look at those two. And if I want to unite them, such as the union, I will end up with 1, 2, 3, 4, and 5, 7, and 9. So I will have 1, 2, 3, 4, 5, 7, and 9. Then I'm going to take the intersection of that. And I next want to focus on A union C. So for A union C, I'm focusing with set A and set C, and I want to unite those two sets. The result of uniting those two sets will give you 1, 2, 3, 4, 5, 7, 8. And always double check this before you get any further. Double check your sets and your elements to make sure they're correct. You know, comma there. 1, 2, 3, 4, 5, 7, 8. And that looks good also. So lastly, we want to do the intersection of these two sets. Intersection describes what is in common. So just by looking, I can see they both have a 1, 2, 3, 4, 5, and a 7 in common. 1, 2, 3, 4, 5, 7. So my answer will be that. All right, and then I want to look and match this with the correct answer. We have to choose one of the multiple choice answers, and that is going to give me C, 1, 2, 3, 4, 5, and 7. Once again, we are given three sets, A, B, C, with a universal set. And it asks us to find A union B union C, the complement of. All right, the complement of A union B union C. So the first step you want to do is grab a rewrite just what's inside the parentheses, A union B union C. And we're going to focus on all three sets and uniting them. So when we unite those sets, we end up with 1, 2, 3, 4, 5, and 7. All right, now that's not what we wanted, but we do have the A union B union C. The next thing we want to look at is compare this to the universal set. So if I place the universal set right below here, the universal set starts with the number 1 and it ends with the number 7. So I will go ahead and list each one of the elements so that we can see the universal set in its entirety. All right. What we're actually looking for is the complement of A union B union C. So the complement means we want to eliminate the items that are in A union B union C. So as we eliminate each one, it just leaves me with the number 6. So the complement of A union B union C is 6. This is a really important slide. It has the explanation of each of the regions for a Venn diagram that contains three sets. So you can see that in this case here, now we have 8 different regions. And region 5, which is right in the center, in the middle, is where all three sets intersect. And this one for region 5, it means A intersect B intersect C. All right, and you can go through each of these. What's important to know about this is when you are completing a Venn diagram, you're making your own Venn diagram and everything is empty, the first place you want to start is with region 5 and fill that in first. The next thing what you want to do is to go out to the little petals, we call those petals, region 2, region 4, and region 6. You want to complete those next. So we'll start with the innermost item first, innermost region, and then you work your way out and complete the numbers that go in there. And then finally what you do is reach out to the what we call the outer petals and complete those. And this will make more sense to you as we work one of the problems. So in this case here, just so you know, it says region 2 is A intersect B intersect with the complement of C. Now, you don't really need to know that because it will be pretty obvious once you go in and work these. But it's nice to be able to identify what each of these regions mean. Again, each of these regions, I'll give that for you to look over as notes. Again, this is an important slide, so take note of it. For example 2, it is asking us to determine sets from a Venn diagram with 3 intersecting sets. So for part A, it wants to know what is set A. So if you take a look at set A, we just write down the elements that are contained in set A. So I'm looking at, I don't know if you can see this circle or not. It's not a good circle, but this is what I'm making. We want to grab all those elements that are contained inside. So it looks like we have a 3, 5, 6, 7, 11, 12. Don't mistake the listings for the regions, the numbers 1, 2, 3, 4, 5, 6, 7, 8 as an element. All right, and that would be part A. For the next one, it is asking us, let me go ahead and switch colors here, make it easier to watch. We have A union B. All right, so we want to unite A and B. So I'm going to take all of A. See if I can get that bolder. All of A, and I'm uniting it with all of B. So everything contained in my drawing there should give me 1, 2, 3, 5, 6, 7. I'm always trying to place these in order. And it looks like we have 9, 10, 11, 12. So this is A union B. So essentially what I did was I grabbed all the elements contained in this region that I'm drawing all these little lines in. Everything there is included in A union B. All right, let's go ahead and get this erased and cleaned up. So for part C, what they're asking us to find is B intersect C. We want to know where circle B or set B intersects with set C. So although I have, let me draw this out. This is my set B. And here is my set C. My little pen's not marking that very pretty. The part that's intersecting, and let's go ahead and see if it'll let me erase where they're intersecting at, is right in the middle. It's kind of a football shape, if you will. And that region that's left over is where they intersect at. So I have B intersect C will give me 5, 7, 9. All right. Let me see if it'll allow me to erase this out a little bit. There we go. And part C is asking me for the complement of C. The complement of C. Now, remember the complement of C means that we're excluding the C. So if I take out everything dealing with C and remove all of it, what I'm left with is not C. So that looks like 1, 2, 3, 4. We have to include region 8 out there. 10, 11, and 12. Let me see if I counted correctly there. 2, 4, 6, 7. There we go. We have 7 elements there. All right. So for the last one, we want A intersect B intersect C. Remember, this one's the most important region that we talked about when you're completing a Venn diagram, one that has blanks in them, there's no numbers or anything, is that innermost region where they all intersect at. So the region intersects in the middle here at region 5, and that is going to give you 5 and 7. So once again, although these are quite busy, just take it one at a time, read left to right, identify each of your sets and focus on whether you're doing the union, the intersection, or the complement. Use the Venn diagram shown to list the set, the complement of A union C in roster form. So remember in the last section, we can always list each individual set in roster form and work this problem out. But what we're going to try to do with this one is just use the Venn diagram. So when we're doing the complement of A union C, remember we want to do what's inside the parentheses first. So I'm going to do A union C. So I'm going to grab set A and unite it with set C. All right, and now that we know what A union C looks like, that's everything inside my drawing, we want to exclude it so that we can get the complement. So that would mean to eliminate everything on the inside, and we will write down whatever's left on the outside of my figure. So that is going to leave me 8, 9, and don't forget 18 out there in region 8. Again, the complement of A union C is going to be 8, 9, 18. And this will tell me to select choice B for my final answer. Use the Venn diagram shown to list the set of A intersect B intersect C. Now, at this time, you should recall that the intersection of all three sets is region 5, which is right in the middle. All right, and inside the middle, it just says 21. So we have the number 21 that we will put down as our final answer. So A intersect B intersect C is equal to 21. Use the Venn diagram to the right to answer the following questions. So for part A, it is asking us to find A union C intersect B. So what I will do first is look at my Venn diagram and identify A union C. So I will grab all of A and all of C. And that is A union C. Next, what I will do is to identify set B, and I'll highlight that in a different color. So B is identified as such. And what we're looking for is the intersection of those two items. So for our trying to do the intersection is what is in common between the two sets. So that would give us region 2, region 5, and region 6 is where they overlap and have a commonality. So I am going to choose answer C as the answer for this item here. A union C intersect with B. The next one we have is to take A intersect B union with B intersect C. So let me go in here and erase my lines real quick, if that'll allow me to do so. Again, we're doing A intersect B, union B intersect C. So the first thing I'm going to do is go in and identify A intersect with B. Remember, where does set A intersect with set B? And that is going to be region 2 and region 5. All right, next I'm going to go in. Let's see, it did not take my highlight, so let me try that one more time. Region 2, there we go, and region 5. Next, I'm going to go in. Remember, since we're doing a union here, I'm looking for B intersect C. So set B intersects set C at region 5 and region 6. Now for this problem, we're looking for the union of those two sets. So again, the union means to write down every region that is included in both sets. So that is going to be region 2 again, region 5, and region 6. So my correct answer that I would choose on here for region 2, 5, and 6 would be answer D for that part B. So sometimes it's a little easier to just use the Venn diagram and do some highlighting on them to get your regions identifiable. All right, and so on that final part C, what it's asking us to do is to identify if those sets are not equivalent or equal or not equal. So in this case here, if you look at the final answers that we had, part A had regions 2, 5, 6, and part B had regions 2, 5, and 6. So I would say that both of those are equal, and I would choose B as my final answer. Use the symbols A, B, union, intersection, and complement as necessary to describe the shaded region. So if you take a look at your Venn diagram, notice that A, the whole set A, is not shaded. So that means everything outside of A is shaded. So I would consider what's outside of A to be the complement of A. So the answer for this is C. So once again, we're looking for the shaded region represented on there. And if you're not included in set A, then anything outside of set A is considered the complement of A. A math tutor working with a small study group has classified students in the group. And it says by whether or not they scored 95% or above on each of the 3 tests. The results are chosen in the Venn diagram to the left. So it says use the Venn diagram to represent the set of solutions who students who scored 95% or above on exam 1, exam 2. So you want to be careful when you take a look at this. The students who scored 90%, 95% or above on exam 1, that is going to be we'll call that set A, if you will. All right, and or means union. Remember, and means intersection, or means union, not exam B. So remember, I'm just calling this my A, set B, and set C. So not on exam B would be the complement of B. So keeping this in mind that you're doing a union, so everything that is an A will be in the final answer. So what I'll do first of all is go and highlight my set A. So I know that these names here are going to be included in my final answer. Ava, Huey, Ross, and Gus. And I'm going to unite those 4 items, those names, with not B. So what I do now is to identify the complement of B is to eliminate B. So I'm eliminate all these names that are contained in B. So what that does, it leaves all these other names, Ava, Huey, Ross, Gus, Jen, Lon, Don, Flo, Pat, Nye, and Ken. That would be my remaining students that would be included in A union, not B. So let me see if I can find the right answer on here. Let's see, Ross and Gus, Jen Lund. So it looks like my answer is going to be answer A. All right, so once again, what I did was we focused on the Venn diagram for students who scored 95% or above on exam one. So that would be my set A. Then we looked at the word or and said this means union. And not on exam two means not B. And once again, I just used the Venn diagram rather than to write all the names out. Construct a Venn diagram using the following sets. So we have sets A, B, and C with the universal set. And we're going to look at this first one where it says A intersect B. So focusing on set A and set B, we are only going to write down what they have in common. So set A and set B look like they have E, G, and H in common. E, G, and H. Next, we're looking at A intersect C. So if you look at set A and set C, what they have in common is A, E, and H. All right, so let me confirm that A, E, and H in common. All right, and the next intersection is B intersects C. Look at set B and set C and write down what they have in common. And it looks like they have E and H in common. B intersect C. They have E and H in common. All right, so my H didn't quite look right. There we go. And lastly, we have A intersect B intersect C. So we're looking for what does A, B, and C have in common? And if we look at all of those, it looks like they all have the letter E and they all have the letter H. All right, so what we can do is it says construct a Venn diagram. So remember when we first fill out the Venn diagram, we have to complete the innermost region first, which is region 5. So I'm going to go into region 5 and place my A intersect B intersect C, which will be E and H. Next, I'm looking for the regions where B intersects C, and that is also E and H. And there's nothing to add on to that. It's already listed. And then I have A intersect C. A intersects C at A, E, and H. E and H is already there, so I will add an A to that next outer petal. And then I have to go, I'm just working my way backwards. A intersects B, shares the letters E, G, H. Well, E and H is already in region 5, so region 2 would be G. All right, next I'm going to go and focus on set A. All of set A has the letters A, D, E, G, H, I, J. So anything that's missing right now, I'm going to place in that region 1. So I do not have a D listed on there. E's already there, G's there, H is there. I do not have an I, and I do not have a J. If I focus on set B, B has a B missing. EGH is already listed, and there's also the letter L. All right, and set C, I have an A. I do not have the letter C, so that'll go out here in region 7, and EH is already listed on there. So then when you take a look at your universal set, what you want to do is identify all the letters that are not represented on your Venn diagram. And at the moment, we already have the A, the B, the C, the D is there, E is there. I do not have an F, so I'll place F out into region 8. Then I have G, H, I is there, J is there, K is not listed, so I'll list the letter K. And L is also taken. So this is your Venn diagram. Remember, start with the innermost region first and work your way out. This slide shows the solution for the last problem that we just completed. So you can see that we did well on that. We did A intersect B, came out to be EGH. A intersect C is AEH. B intersect C, EH. And A intersect B intersect C is EH. So we did all of those correctly, and then it says to complete your Venn diagram. So the first place that you start out with is, I'll go backwards and I'll just write the number 1 right here. This is what I filled in first, and that was region number 5, the EH. Then I went to B intersects C, and the two regions where B intersects C is going to be region 5 and region 6. All right, so that's region 5 and region 6. Let me put that on there so you can see. And this was region 5 right here. Next, I went to A intersect C, and the regions that affect A intersect C will be region 4 and region 5. All right, so regions 4 and 5 should share those letters A, E, H. And since EH is taken in the center with region 5, that leaves region 4 with A. All right, and the next thing we went to was A intersect B. And A intersect B is region 2 and region 5. And region 5 again already has the E and the H, so that left region 2 with the letter G. And we just kept working our way backwards. Then we looked at the entire set A, and whatever was already used in set A for the regions 2, 4, and 5, we left the rest in region 1. Then we completed region 3, then region 7, then lastly we went to region 8. And that's kind of like the order you should follow when you're completing these Venn diagrams. So this is a different take on using a Venn diagram. This says the chart below shows the most popular vacation destinations booked at certain travel agencies in 2003, 2004, and 2005. So those are the years that they recorded the names of the most popular vacation destinations. And it says on here, use the Venn diagram to the right to indicate which regions 1 through 8 St. Lucia should be placed. So we want to know where St. Lucia should be placed. So I'm going to look under the column of 2003 and see if there is a St. Lucia, and there is not. And column for 2004, St. Lucia is listed. And for 2005, St. Lucia is listed. So you can see that St. Lucia should be in the regions where the circle for 2004 and the circle for 2005 intersect. All right, so it's going to intersect, 2004 and 2005 intersect right here in this football shape, region 5 and region 6. All right, so remember, St. Lucia is not listed in the year 2003. So that would eliminate using region 5 because region 5 includes 2003. So the answer would be region 6 is where we need to list St. Lucia. The chart shows 3 health indicators for 7 regions. Let the universal set, the set of regions, equal the set of regions listed. So set A, the set of regions with male life expectancy that exceeds 75 years. B is equal to the set of regions with female life expectancy that exceeds 80 years. And C, set C, is the set of regions with fewer than 400 people per doctor. Construct a Venn diagram that illustrates these sets. So I'm trying to think of a way to make this a little easier. Let's focus on identifying the sets. The table is the information. We have to create our sets. So the set A is male life expectancy that exceeds 75. So male life expectancy is going to be on the second column right here. And I'm going to just move vertically down, and I'm going to put a little dot on anything that is 75, greater than 75 years of age. So that would be this one right here. And we'll just keep going down. Anything that's above 75. All right, so those are my male life expectancies that are greater than 75. Next, I'm going to look at set B, and set B is female life expectancy that exceeds 80 years. So again, I'm going to go over to the female life expectancy column, and I'm going to move vertically down and put a little dot in there, anything that exceeds 80 years. So that would be this one. Here's another one right here, and the very last one it looks like. And that should be it for the female life expectancy greater than 80 years. Set C is the set of regions with fewer than 400 persons per doctor, so less than 400. So I'm going to the last column. We have the persons per doctor with less or fewer than 400 persons. That would be this 240 here is less than, 170 is less than 400, and also the 380. All right, so I just labeled each description that would be located on my chart. Now what I'm looking for, remember, these are considered your sets. This is set A, this would be set B, and set C information, those little solid dots. So what I noticed on here is that if you look at region 3 here has all 3 of these items with a dot. So that means all 3 sets would contain an R3. All right, this also occurs for this R7. Region 7 is marked for each of the 3 sets. So that means inside the middle in region 5 on my Venn diagram, I should have R3 and R7. Just looking at our selections, only B, as in beta, has that R3 and R7 in the center. So process of elimination, you would choose answer B. All right. The next thing you can also take a look at too is that the R2, let me highlight that in yellow, is set A and set B are intersecting. Where set A and B intersect, you'll have R2, and that is true for that answer B. And then we can also take a look at, let me see if I can grab a different color here. R5 is going to be set A and set C. This is set A and set C that has those little dots. So R5 would be the intersection of set A and set C, which also is the case right here. So for this one, our Venn diagram that we would choose is the second one, B.